Hello and welcome to our presentation on how instructors can impact students' perceptions of computation as a physics practice. We're going to start with the premise that students' perceptions of computation might differ from those of the physics community. This is pretty well agreed upon among physics educators who incorporate computation into their courses. We're going to talk about some interviews we conducted with 5 upper-level physics majors and 3 physics instructors to study how students' perceptions of computation mimic or differ from their instructors after completing a computationally integrated physics course. And we're going to conclude with this notion that the students' varied trajectories into the physics community have an influence on their perceptions of computation. So it's commonly agreed that students don't often realize that STEM careers heavily use programming, and that this is going to impact their ability to navigate through the physics community or the broader STEM community. So for example, while an instructor or a practicing physicist might say that computation is great and every physicist uses it and it has all of these purposes, the student with the purple text here might be thinking about computation in a more limited fashion in the context of a course and a particular language and particular set of activities. And so we pose the research question, how do the students' perceptions of computation mimic or differ from their instructors' perceptions after learning computation in a physics course? So in order to study this question, we interviewed 5 physics students and 3 physics instructors who recently completed a computationally integrated physics course. These 3 upper-level courses took place in the fall 2020 semester. In the curriculum at our university, there is no formal computation established prior to these courses. So for many of these students, this was their first experience with programming, although a few had taken Programming 1 through the computer science department. And we should note that a few of these students were enrolled in more than one of these courses such that their computational experience was reinforced. And so we interviewed the students and instructors in spring 2021, and in this talk we want to focus on the reasons that each of the students and instructors identified for using computation in physics. Let's start by looking at the reasons for computation that the students identified. We were pleased to see that the students all identified many reasons that align with those of the physics community. Things like mathematical accessibility to new problems, the accuracy afforded by using a computer instead of doing calculations by hand, data analysis processes, the efficiency of computers, etc. All of these line up with the way practicing physicists talk about using computation. However, we did notice 2 interesting features in all 5 of the student interviews. First, within a given interview segment, so in response to a particular question, the students tended to discuss reasons for computation in isolation. So a student would talk about visualization, and then later they might talk about efficiency, but they would never really talk about efficiency and visualization in the same sentence or in the same interview response. And over the entire interview, each student tended to favor 1 or 2 reasons and mention one of those reasons over and over again, and maybe mention a couple of others, but not really spend significant time on them. Looking at the reasons that the instructors identified, we found similar reasons to those of the students. So it seems like the instructors' motivations for using computation rubbed off onto the students. However, we see some different features in how the instructors talked about computation. So within a given interview segment, in response to a particular question, the instructors would chain together several reasons. Like you see the 2 figures over here, they can't stop talking about all the great things they can do with computation. And over the entire interview, each instructor discussed many reasons in contrast to the students who tended to focus on 1 or 2 reasons. So this leads us to a model where we consider the trajectories that each student is on as they navigate the physics community of practice, based on where the students are coming in from, their prior experiences, the other communities that they're committed to. They see 1 or more of these reasons for computation in a little bit clearer focus than the others because it's more on their current trajectory than the others are. The instructors are at the center sort of holding up all these reasons like banners, but the students tend to focus on the ones that are more personally applicable to them. We think this model is important because it helps us acknowledge the uniqueness of the students' trajectories and how that impacts their stages of learning throughout the process, and how each of those processes is going to be different for each of these students. So thank you for coming to our presentation. Do please check out the other talks by our research group, including part 1 of this presentation on computation interviews in this same session. Thank you so much for watching. We look forward to talking with you.